Hello friends, in today's question, a wooden plank of length 1 meter and uniform cross section is hinged at one end to the bottom of the tank as shown in figure. The tank is filled with water up to the height of 0.5 meter. The specific gravity of plank is 0.5. Find the angle theta that the plank makes with the vertical in the equilibrium position. Exclude the case theta is equal to 0 degree rather. So we have a plank and this is water, and we are given that the height of this water is 0.5 and this is a plank which is making an angle of theta with the vertical. So in this case, for equilibrium position, we have to remember that there will be two forces acting on this plank. One force will be the weight, that is mg, that will be acting on the center of gravity of this entire plank, and another force will be the buoyant force, which will be acting in opposite direction, that is upward, and that will be dependent only on the length of the plank that is in the water. Okay? It is not dependent upon the extra length which is outside the water. So this we have to remember in this case. Let me redraw this figure here. So this is making an angle theta, and we have a vertical height that is 0.5. Let us call this as O, and this let us call as D, and the center of gravity of this OD, that is weight that will be acting, let us suppose is somewhere here, so it will be acting in downward direction in mg, and we are going to have, and let us call this as point as B, and you can say the length of the plank inside the water, let us call that as point C. So OC is the length of the plank that is inside the water, and the buoyant force will be acting only on this OC length, and let us suppose that is acting somewhere here in this direction, and let us call that FP, and this point let us call as A. So we have two forces, FB and mg, and they will be producing a torque. One will be clockwise, another will be counterclockwise, and at equilibrium both the torque should be equal. So therefore we can say, and other than you can say these two forces, there will be also a force that will be acting at this point O, but still but we are going to take a moment of, you can say the torque rather, on the with respect to point O, so that value will be equal to 0. Okay. So let us start from there only. There are three forces acting on the plank. Three forces acting on the plank. First will be weight, that is our mg at the center of the plank, and that is means point B. Next will be buoyant force, downward direction, forgot to mention downward, and next will be the buoyant force, which acts only on the submerged part of the plank. Submerged part of the plank, that is OC, at point A. At point A, and that is upward. And last is the force from the hinge at O. Force from the hinge at O. like I said, we are going to take, you can say, moment of all the forces about point O. So this value, last one, will be equal to 0. Okay. We say taking moment of all the forces about point O. Therefore, moment of hinge force will be equal to 0. And for equilibrium, vertical equilibrium rather, now we have only two forces. One is the weight, which is acting in the downward direction, and the buoyant force will be upward direction. So moment because of the weight and the moment about because of the buoyant force should be equal. You can say that moment because of weight, and that will be over clockwise, should be equal to moment due to Fp, and that will be anti-clockwise. So let us find out the moment, respective moments. And in order to find out the respective moment, first of all, we are going to find out the length of the plank which is submerged in the liquid. And the length of the plank that is submerged in the liquid is our OC. So we are only interested in this OC. This is our C, and this is point D, and this is the height of the liquid, which is given as 0.5, and this is our theta. So we are only interested in OC. So we write the length of plank inside the water. Length of the plank inside the water, which will equal OC, and this is a 90-degree angle, and we can write that our OC will be equal to 0.5 secant of theta. So this was our OC. So based on this length, we can find out what will be the value of the buoyant force that will be acting at point A. So we have this buoyant force, and this is point A. So we can find out what will be its value. So we can say for A as the cross-sectional area, the buoyant force on the plank, the buoyant force on the plank, which is our Fp. So Fp will be equal to volume, and we have density of the water, and this is our G, and this volume is volume of the plank. So let me write it Vp. So this, from here we can say Vp is the volume of plank, and rho W is density of water, and G is acceleration due to gravity. So we can write our Fp will be equal to A multiplied by OC, and we have here rho W multiplied by G, and OC is 0.5 secant of theta. So this is area multiplied by 0.5 secant of theta, and we have rho W multiplied by G. So this is the amount of the buoyant force. Now we can find out, you can say, the moment because of this buoyant force. So we can say the moment because of FB, moment because of buoyant force, that will be equal to you can say the applied force and the perpendicular distance. That is the basic formula for the moment force. So applied force is Fp multiplied by the perpendicular distance. So let us call that moment of buoyant force is mFb. Therefore we can write Fp is our A, 0.5 secant of theta, and we have rho w multiplied by g, and the perpendicular distance will be equal to 0.5 divided by 2, and we have here secant of theta multiplied by sine of theta. Okay, I think this is complete. So we get this as moment of buoyant force. Similarly, we can find out the moment because of the weight. Moment because of weight. So this is our OD, and we have a weight in the downward direction, that will be mg. This angle is theta, so this angle will be also equal to theta. So therefore we can write moment because of the buoyant force, weight, let us call that as mg is equal to, we have here force, that is our mg, multiplied by L by 2, and we have sine of theta. And we substitute the value of mass, so we get moment because of this mg will be equal to, we have here A and length, G density of the plank, and we have L by 2 sine of theta. In the starting, we just mentioned that because of the moment of the weight is equal to moment of the buoyant force. So we equate. So let us call this equation number 1, and this is equation number 2. From equation 1 and 2, moment because of the buoyant force will be equal to moment because of the weight. So we substitute the values. Now it is a simple calculation is left. Rest is done. So we equate them, and we get this as ALG rho p, and here we have L by 2 sine of theta, and this will be equal to A 0.5 secant of theta, and we multiply it by density of water. Then we have G, and we have 0.5 divided by 2 secant of theta and sine of theta. So area goes with area, G cancel out with G, and here we have I think rest is done. Anything else cancels. Length is doesn't matter because length is given as 1. So I think this completes it. We substitute the value. Length is given as 1, and we have here rho p, and this will be 1 by 2 sine of theta, and from here we have 0.5 here and 0.5 here, so 0.5 square 1 by 2, and Yeah, sine also cancel out. Sine theta and sine theta also cancel out. So this we get as secant square theta also. Secant square theta, and we get rho of W. So here 2 and 2 also goes away. Sine and theta cancelled already. So we get here rho of P is equal to 0.5 whole square secant square theta. Let me divide this rho of W here, because we are given that the specific gravity of the plank is 0.5. Okay. So we are given specific gravity of plank is 0.5, which basically means that the ratio of the density of the plank with the density of the water is 0.5. Okay. So we substitute here, we get this as 0.5 is equal to 0.5 square secant square theta. Square goes with this 0.5, and we are left with secant will be coming now as cos. So we get cos square theta is equal to 1 by 2. So this gives cos of theta is equal to 1 upon square root of 2, and this finally tells us that theta will be equal to 45 degree. Okay. This is the angle in equilibrium position with vertical. This is the angle made by the plank with vertical in equilibrium position. So in this question was quite, you can say, simple, except that we have to remember that the weight will be acting for the entire plank rather, and the buoyant force will be acting only on the part which is submerged in the water or liquid. That's the only difference or important point in this question. Rest is the simple equations, equating them for the equilibrium, and we are going to get the final answer. So this completes the question. Thank you.